Welcome back to the GCSE Maths Pro YouTube channel. Today's video is a summary of everything you need to know for the angles topic as a foundation tier student. So we're going to first go through an introduction, which is looking at angles on straight lines, angles around a point, angles in triangles including isosceles triangles. Then we'll move on to angles in polygons, and finally angles on parallel lines. If you would like to look at any of these videos individually in more detail, they will all be linked down below in the description. So the first one we have here is ABC is a straight line. Work out the angle X. So we've got our straight line here. The key piece of information we need to know is that the angles on a straight line add up to 180. So let's just say I get this line here. Basically what we're saying is this angle here is 180 degrees. So knowing that, having a look at what we've got here, we have our straight line ABC and then it's been split. So we know that this left-hand angle is 28. We want to know what the rest of it is. So that creates the same shape as you can see over here. We know that all of that should add up to 180. So to work out X, all I have to do is 180, because that should be the total, subtract whatever else is there, which is 28, and then that will give me X. And that is 152 degrees for X. So you do need to memorize this information. The angles on a straight line add up to 180. The next one we have here is ABC is now a right angle. So you might have seen it drawn with this little square. Work out the angle X again. So a right angle, we need to know, is 90 degrees. Okay, if you see this little square, or if it mentions a right angle in those words, it's 90 degrees. The logic is now the same as last time. If we know that this whole angle must be 90, and there's two parts that it's been split into, 63 and X, all I will need to do is 90 subtract 63, and that should give me X. So that should be 27 degrees for X. Again, that's just something we'll need to memorize. The next one we have here is the angle around a point. We've got this point here which has been split into three sections. We've got 18 degrees, we've got this right angle again, so that's 90 as we now know, and then the other part is X. We just need to know what the total of all of these degrees added together should be. So the angles around a point, if you were to do a full rotation, is 360 degrees, again, something we just need to memorize. So I know that X plus 18 plus 90 must equal 360. So to work out X, again, I'm just going to be subtracting. I want to add together the 18 and the 90 and take that away from 360, which gives me 252 degrees. And again, that would be X for this case. So angles around a point add up to 360 degrees. Now we're moving on to look at some triangles. The main thing about triangles that we need to know is that they all add up to 180. Doesn't matter what type of triangle it is, all three angles will add together to make 180 degrees every single time. So in the case of this triangle here, we've been given two of the angles and the only one missing is X. So I can do 180, subtract both of these two angles added together. So 15 and 62, and that will give me X, which is 103 degrees. So if you're given two angles in a triangle, you can always work out the third, as long as you remember that they add up to 180. Okay, this next one is again a triangle, but it's now more specific. So ABC is an isosceles triangle where AB equals AC. So they mean AB is the line, so over on the left side, and AC. They are equal to each other, they are the same length. Another way that this can be demonstrated is by these little lines here. So if you see any shape, could be triangle, could be other shapes, where you see two little lines, that means that those two sides are the same length. So sometimes they might not mention that it's an isosceles triangle, they might just show you it by drawing these lines. So you need to be familiar with what those two things mean as well. It means they are the same length. So we've got an isosceles triangle, that's obviously where we've got two sides that are the same, isn't it? We want to work out the size of angle X. So as you can see, we've been given one angle, and then obviously X is another one. If this was just any other triangle, we wouldn't be able to work out what X is because we would need two angles. That's why we have this extra information about it being isosceles. if we've got two sides that are the same, we should know for isosceles triangles that therefore two angles are the same as well. So an isosceles triangle, if I draw it like this, where these two sides are the same, the base angles are also the same. I'm using the word base very loosely. In this case, it is the base. It looks like it is the bottom side. However, it could be rotated, right? It could be upside down, and those two are the same. It could be sideways, and these two are the same. It's not necessarily the two angles that are just at the bottom vertically. You have to know that it's the base in terms of the bottom angles for each of these two sides that are the same. It is not this top angle here where both of those lines connect. Okay, it's not that. These two angles at the bottom are the same. So in this case, it is rotated correctly, so we can assume that angle B is also 74 degrees because B and C are both the base angles in this case. So now that we know that, we have actually got 2 out of 3 angles, so we can carry on with the fact that obviously any triangle adds up to 180. So I just need to subtract both of those angles that I now know to find out x. That should give me 32 degrees for x. Okay, so again, ABC is an isosceles triangle, where in this case, AB is the same as BC. Okay, so you can see in this case it has been rotated, but we've still got these two little lines to signify which two sides are the same. So, very similar scenario, but now x is in a different corner. We've been given the 18, and we've been given x. We know that for isosceles triangles, two angles are the same. And this is where it's really important that we get which two angles correct. So some of you might think, oh, it's 18 and then this one is also 18. Okay, again, it's not like that. Double check which two sides are the same, and then it's the bottom of those two angles. When I say the bottom, I mean, I know vertically in this case, we're going down, but do you see what I mean where it would be A and C? Those two are the same. If you were to rotate, if you had a piece of paper with this on, you could rotate it to look at it properly. It is not the angle where both of those sides connect, okay? So it's not B in this case. So this one here, angle C, is also x. Okay, but how does that help us? We technically still only know one angle. Well, what we can do in this case is we can still take away the 18 and figure out what's left. So 180 minus 18 is 162 degrees. Now, the 162 degrees is shared between angle A and angle C. Now, specifically, we know that both of those angles are exactly the same. So the 162 degrees is shared equally. So that means I can divide it by 2, and that should give me 81 degrees. So you can see how working out angle problems with isosceles triangles can be different depending on which angle you're given and which two are the same. This one was slightly different to the previous question because x was actually both of the base angles. It wasn't the top angle here. So there's one main formula that you will need to know for this topic. You've probably forgotten about this topic because normally you do it in like year 8, maybe year 9, depends on your school, and you've probably completely forgotten that it even exists, but it can come up in GCSE anyway, and the formula definitely won't be on your formula sheet. So the main formula, if you want to work out the total angles or the total degrees in any polygon, let's break that down first of all. Polygons are just 2D shapes, right? So any 2D shape, including pentagon, hexagon, heptagon, octagon, you know, that kind of thing. Any 2D shape is a polygon. It's just like an umbrella term for those shapes. And for example, you should already know that the total angles, total degrees in a triangle is 180. And in a quadrilateral, which is a 4-sided shape, is 360. Those are the two that you should have memorized. Beyond that, we don't necessarily need to memorize it because we can use this formula. Now, this formula does work for triangles and quadrilaterals as well, but those two you should already know. So you're going to do 180 multiplied by n minus 2. Now, n is the number of sides. So just for example, a pentagon has 5 sides. If you wanted to know what the total degrees or total angles in a pentagon is, you would do 180 times 5 minus 2, which is effectively 180 times 3, and that should give you 540 degrees. Okay, you don't need to memorize that pentagons add up to 540 degrees. You can just use this formula for any 2D shapes. Now this second one here, as you can see, is basically the same at the top. We just added a little bit extra. That would be for any polygon. It could be a regular pentagon where all of the sides are the same. So, roughly something like that. Imagine that all of those are the same. Or it could be a pentagon in terms of this. This is a pentagon, isn't it? We've got 1, 2, 3, 4, 5 sides. That's not regular though. Either way, all of them should add up to 540. But in a regular pentagon, obviously all 5 angles individually are the same. So if you want to find out the interior angle, so one interior angle in a regular polygon, so any shape where all of its sides are the same and therefore all of the angles are the same, you would do 180 times n minus 2 to work out what the total is, and then just divide it by the number of sides to find one of those angles. So those are the main two formulas. They're basically the same thing, just a little bit extra here. Now let's actually go through some questions so you can see what we're talking about and how to use them. We've got here that angle A is twice the size of angle B. Work out the size of angle A. So here we can check what shape we've got. Again, it is irregular, but that's fine. So we've got 1, 2, 3, 4, 5 sides, which means it's a pentagon. I'm going to work out what the total degrees in a pentagon is. So 180 times by 5 minus 2, which is effectively 180 times 3, which gives us 540 degrees for a pentagon. Now though, this is the bit that's kind of difficult. How do I split this up? Because A and B aren't exactly the same. I like to bring algebra into it. You might want to use a ratio. I always label the smallest angle with X. So B is obviously the smaller one, right? Because A is twice the size of B. So A is 2 times as big. So if that's X, what does A have to be? And I'm deliberately using the same letter here in terms of X. If that's twice the size, that must be 2X. So do you see how I could create an equation here? We've got 77 plus 149 plus 71 plus the other two angles, which is X and 2X. We know that that must equal, or must add up to 540. And the reason why I've used the same letter, so I've not used X and Y, for example, to show the two different angles, is because I only have one equation. If you've only got information to give you one equation, you can only use one letter. If you had enough information for two equations, two different equations, you could use two, like simultaneous equations. But we don't here, so that's why I'm using X and then therefore 2X. So if I simplify this and add up all the like terms, collect the like terms, so we get 297 plus 3X. It's literally just an equation, so I just need to solve this. So 3X is therefore equal to 243, and then divide by 3, X is 81. Now, the only thing here is that when you've solved the equation, you can kind of think that that's the final answer. Just double check. That's what X is. So we know that B is 81. However, do you see that the question was work out the size of angle A, which is actually 2X. So therefore, to find angle A, I just need to double 81, which is 162. And there we are. There's my answer. So we can also use a bit of algebra if you find that helpful as well. Okay, so this one is just work out the interior angle of a regular hexagon. So the interior angle, if I draw a hexagon here, regular again means that all the sides are the same. So that's the same. All, in this case, 6 sides are the same. And if all 6 sides are the same, then all of the angles inside must also be the same. So when we say interior angle, we're referring to literally just these angles that are inside. It's obviously got 6 equal interior angles because of the keyword regular. So to work out basically just one of these angles, we're going to use that second formula that we had at the start. So you can build it yourself, you don't necessarily have to memorize it. I obviously want to know what all of these angles add up to in a hexagon, and I don't necessarily know that off by heart. So I'm going to use my formula, 180 times by n, which is in this case 6, minus 2. Now that would give me the total of all 6 angles, but I actually only want to know 1. And because I know that all of the angles being regular are equal to each other, they're all equally distributed, I can just divide this total by how many angles or sides that there are. There are 6. So it's the same formula, I've just kind of added this extra bit to work out just one angle when it's specifically a regular polygon. So effectively the total of all of the angles is 720, and then if you divide that by 6, we get 120 degrees for each of these angles. Again, I know I'm repeating myself, but this is specifically for regular polygons. This method here wouldn't work if you've got an irregular one, like some of the previous ones we've seen. So that's an interior angle. The next question is now the exterior angle. So work out the exterior angle in a regular octagon. So if we get an octagon here, again, regular, meaning that all of the sides are the same, therefore all of the angles are the same. Now, we can use our formula to work out the interior angle. However, we are looking for the exterior angle now. Now, sometimes you might think that the exterior angle must be the bit on the outside, but actually it's not that. If I were to continue a straight line here, the exterior angle is this part. So not the whole of the outside, but if you imagine that each of these carried on as a straight line here, straight line here, straight line here, it's all of these little bits. So first we need to work out the interior angle, and then we can use that to work out the exterior angle. So we're going to use the same formula, 180 times 8 minus 2 in this case, over 8 to work out one interior angle. So the total degrees in an octagon is 1080, therefore individually each interior angle is 135 degrees. We should know how to work out the angles on a straight line. Angles on a straight line, that whole thing there, add up to 180. So if I know that part of it's 135, all I need to do to find out the rest of it, the exterior part, is 180 minus 135 in this case, which leaves me with 45 degrees. So that is the exterior angle. Okay, really straightforward, but if you didn't know what it was, again, you might assume that the exterior angle is all of this. That's what I assumed when I first saw it. But it's not. It's as if it were on a straight line. So now we're moving on to a slightly more advanced question. We've got here that each interior angle for a regular polygon is 144 degrees. Work out the number of sides the polygon has. So do you see how now they've given us the interior angle, and we're effectively going to have to work backwards to find out the number of sides originally. That's why they said polygon and not being more specific. So we're going to use the second formula because they have told us the interior angle specifically, one of them. So we're going to do 144 is equal to 180 times n minus 2 over n, this time because they've given us one interior angle for a regular polygon, not the total of all the angles. So I need to divide it by n. So I've set up my equation. They've asked me to work out the number of sides, which is n. I've got an equation with just one letter, so that's perfect. I know it appears twice, but it is the same letter. So now I can almost forget about the context and just solve the equation. This is just algebra. So I'm going to want to get all of the n's together on one side of the equation and all the numbers on the other. Because this is a linear equation, it's just n, it's not squared or anything harder like that. So I'm going to first deal with this fraction, because fractions are always quite annoying in equations. I'm going to multiply by n. You can always move the letter itself, that's fine. So I'm going to multiply by n to move it across, and therefore I'm opening up this fraction, it's no longer there. Now, depending if it's a calculator question or not, you can either divide by 180, but obviously that's going to end up being a fraction. Or, what I would recommend if you don't have a calculator, if it is a non-calculator question, is just expand the brackets. So 144n is 180n minus 360. Now, it's looking a little bit better, but I still have n in two places. So I want to have a positive number of n's. I'm going to move the smallest value, which is 144, across. So we get 0 is 180n minus 144. Leaves me with 36n minus 360. I'm going to move the 360 over to make it positive. So we got 360 is equal to 36n. The last thing I need to do is divide by 36. So I get 10 is equal to n. Now, it says work out the number of sides. The number of sides we know is represented by n, so that is just my answer. There are 10 sides. So, in other words, it's a decagon. So this is why this formula is so important, because we can also use it to work backwards if they ask us to work out number of sides. If they ask you whether something is possible, they say this is the interior angle, is it possible? You're looking to get a whole number. Obviously, you can't have a decimal number of sides. It can't be like 2.5 sides, can it? It has to be a whole number of sides. So your n value should always come back as a whole number. If you get a question like this one where it comes back not as a whole number, you've done something wrong. Just go back and check. If there's a question where they say, oh, there's this value for interior angles, is that possible? Then you can work it out. If you get a decimal, you can say, well, no, that's not possible, because it has to be a whole number answer. So just double check that one. So this is the page that you might want to screenshot, you might want to make your own notes for. These are the 4 types of angles we'll be using, specifically for angles on parallel lines. Obviously, you'll also need to know just general angle facts as well, like angles on straight lines, angles around a point, some triangles, some isosceles triangles. All of that was in part 1, so if you haven't checked that out, I will link it here, and it will also be in the description at the end if you want to go through it as well. So we've got 4 angles we need to memorize. We also ideally need to memorize the names, just because sometimes they ask you to write a reason for each stage of your working. That's normally only maybe 1 extra point, but it might be worth having. So the first one, I think the easiest one, the one that most people recognize, are called alternate angles. But if you're working through a question, I tend to use letters. So I'm looking for a Z shape. Now, that Z shape could be like this, pretty straightforward. It could be upside down, back to front, rotated, whatever. But as long as you can see a Z, then I've got written here, those angles are the same. So here we've got our Z. It could also be the back to front Z, this one here. Those two are the same. Any rotation of a Z are called alternate angles. Unfortunately, the word alternate doesn't really match with the letter Z, but if you find it easier to use the shapes to look for specific angles, then go for it. The next one we have is corresponding angles. These are in the shape of an F. So as you can see here. These 2 angles are also the same. Again, it might look like an F. In this case, it might be back to front, it might be upside down. So for example, here is not only back to front, it's also upside down. Those 2 angles are the same. Any version of an F, the 2 angles are the same. The third one, which actually isn't really related necessarily to parallel lines, this is just 2 lines crossing each other, but it kind of just comes up in this topic, are called vertically opposite angles, and you are looking for this kind of X shape. In my head, it kind of looks like a sand timer. I don't know why I always think that, but either an X or a sand timer. These opposite angles are the same. In that case, obviously, these 2 would also be the same as each other as well. Got those 2 are the same as each other, and then these 2 are the same as each other. So 3 out of 4 types of angles are basically showing you which 2 pairs of angles are the same. The last one though, which is called co-interior angles, I think you can also call it just interior angles, and we're looking for, I've written C here, it could be like an N or it could be a U, it depends on the rotation, right? So here it's kind of a boxy C. These 2 angles inside, they are not the same. You can see that, I know nothing's drawn accurately, but you can quite clearly see they're not the same. These ones add up to make 180 degrees, okay? They add up to 180. So that's the only one that is slightly different. Now again, it could be any rotation. So it could be this one here. These 2 angles add up to 180. If your parallel lines are vertical like this, then in that case, this is where I'm saying it could be like an N shape if you think of it like that. Those 2 add up to 180. Or like this. Those 2, that's kind of a U shape, those 2 add up. So whatever letter you want to use for that one. But you must remember that you've got 3 where the angles are the same as each other, and then 1 where they add up to 180, okay? But those are all 4 that you need for this topic. So feel free to take a screenshot. Again, as I said, make a note whilst we go through these next few questions. You might want to have something to refer back to. So for our next one, we've got work out the size of angle X. So we've got 2 angles given. We've got obviously parallel lines, and then within that we've got this triangle that's been created. So just bear in mind that you can also use any information that you know about any angle. So triangles, straight lines, around a point, as I said before, anything. But this one, what I'm thinking is we've got a straight line here. I know that all of that, so those 3 sections, should add up to 180 as a straight line. So can I just work out what this one is here? This piece here. How can I work that out? Well, what I would do is use the 98. They're not going to give you information that you don't need, okay? If they're giving you 2 different angles, you're going to need to use both. So here we've got 98. I'm going to use, again, co-interior angles to work that out. That's the way I've chosen to do it. So we've got 180 minus 98 because co-interior angles add up to 180. They're not the same, which should give me 82 degrees. So this is 82. Now I can just go with angles on a straight line. So 180 again, because obviously angles on a straight line are also adding up to 180, minus 64 plus the 82, which gives me 34. So therefore X is 34 degrees. And I've written the reasons there as well, just in case they do ask you. Okay, so that's it for that one. Again, you might have worked it out in a different way. That's absolutely fine. As long as you've got the answer being 34, then that will be correct. Okay, so the next one we've actually got here, if you have a look, is a parallelogram. We've got a pair of parallel sides horizontally, and then these have got double arrows because they're showing that those two lines are parallel to each other, but obviously are not relating to the first pair, right? They're in a different direction. So we've got a parallelogram here, and then we've also kind of created like a big triangle, a small triangle. That's what we've got going on. So again, work out the size of angle X. Okay, X is all the way over here. We're obviously going to have to start somewhere on this left side because that's where we've been given the information. Something you might not necessarily know about parallelograms is that the opposite corners, the opposite angles, in other words, are the same. So this one here is also 72. And the reason why that works is if I were to extend these lines, so for example, if I extend those lines there, that one's obviously 72 because of those vertically opposite angles, isn't it? And if you think about it, this bit here is effectively a replica of this, isn't it? If you look at it like that. And there's loads of other ways to explain it, but that's just one of them. So opposite angles in a parallelogram are the same as well. That's another fact that might be helpful. Now that I've got that, if we kind of try and ignore the parallelogram and just focus on this big triangle here, roughly here, do you see how I've got two angles and then the missing one is X? So to work out X, I just need to do 180 minus 59 plus 72. So now we've used both of those angles, which gives me 49 degrees, so therefore X is 49. So we've got two steps, but often you might have one step that's parallel lines, or one or two, and then one other step or two other steps that are not parallel lines, they're just angle facts in general. Another way to do this one would be to use corresponding angles. So the corresponding angles are the F angles, so first of all, that's a pretty obvious F, so 59, and then this one would also be 59. Then, using the same logic, we've got 72 over here, and then you might have used corresponding angles again. If you didn't necessarily notice the big triangle, that's fine. You might use corresponding angles like this. It's a back to front F, still works. So that's 72. And then you might just focus on this small triangle here. A little bit longer, but again, you still get to the same point at the end. It doesn't matter if you find the fastest way or the longest way. As long as you've kind of figured out any way to get to the same answer, then that is absolutely fine. Okay, so for our final one here, it's a little bit more complex. So we've got, again, obviously work out the size of angle X. We've been given 3 angles this time. And we've got this kind of awkward triangle in the middle that doesn't quite touch all the corners to the parallel lines. Looking at this, again, I've got this straight line here. So that's making me think that I kind of want to know what this angle is here inside the triangle so I can use angles on a straight line at the end. That's what I'm thinking in my head. Doing that, I'm kind of working backwards in my head, like what steps do I need to take? The last step is I'm probably going to do angles on a straight line, so therefore I need to work out this angle. To work out this angle, I need to know the other angle in the triangle as well. And you see how I'm going backwards. To work out this angle, I've got another straight line up here, so I want to know that angle. And you see how now I've kind of created the steps in my head. Sometimes that works, sometimes it doesn't, but that's just me planning in this case. So the first thing I want to do is work out this angle here. And again, I can use the co-interior angles. So the first thing is 180 minus 83, because co-interior angles add up to 180. So that's 97 in this corner here. Now I can go and do angles on a straight line for all of this to work out the angle inside the triangle. Again, we're just using a lot of 180 at this point. 180 minus 17 plus 97 gives me 66 degrees inside the triangle. So that's for the angles on a straight line. Now I can work out this final angle here by using the triangle. Again, another 180, but all 3 of them are for separate reasons. So 180 minus 52 plus 66, which gives me 62 degrees for this angle here. And finally, we can use angles on a straight line again to work out X. So 180 again, minus 62 plus 83 gives me 35 degrees, and that is X. So X is 35. Now, as I said before, that's one way of doing it. There are normally multiple different ways. So I'm going to show you another example of how we could work this out. So another way to work it out is using alternate angles. So there's Z angles. It doesn't look as much of a Z here, but it effectively is. The 83 is technically the same as all of this. So the 17 plus this one in the middle. So you might find this a more direct route. So to work out this angle in the triangle, we could use alternate angles. and do, okay, that must be 83, so 83 minus the 17 will give me what's just in the triangle, which as we saw before is 66. And then you could carry on from there in the same way. You could work out this angle here and work out x. You might find that more direct. There are loads of different ways of doing it, some that are longer, some that are shorter. As long as you end up with 35 at the end, then that's absolutely fine. So thanks for watching this video. If you found it helpful, make sure to like and subscribe. And again, if you want to check out any more questions or any of these videos in more detail, they will be linked down below in the description.